My dear students, in today's video, I will teach you how to convert block diagram to signal flow graph. It means if there is some complicated block diagram problem is there, then we can solve easily by converting to signal flow graph. So to convert this signal flow graph, we have to follow some steps so that we can easily convert the block diagram to signal flow graph. Then we can find the transfer function of the system. So first step, that is step 1, step 1, replace all variables summing points, take up points to nodes. That is, for one summing point we will convert it to a single node. Similarly, for takeoff point also we can convert this to a single node. And for variables, that is for input variable, we can replace by a single node, and for output variable C also we can replace by a single node. So step 2, if takeoff point placed beyond summing point, it can be replaced by a single node. Then step 3, if the takeoff point placed beyond the summing point, this is the case, this is the takeoff point that is beyond this summing point, then we can replace this by a single node, or we can replace by two nodes with gain is equal to 1. So step 3, if takeoff point ahead of summing point replace by two separate nodes. And step 4, replace input and output by two separate nodes. So these are the steps to follow for converting block diagram to signal flow graph. So now this is one example. Now we will convert this block diagram to signal flow graph. Then how we can easily convert this block diagram to signal flow graph? The best way To convert this block diagram to signal flow graph, first we can replace this input variable, that is R, by a single node. So let us this is your R. Then this takeoff point again replaced by a node. Let us assume that that is your x1, and this summing point replaced by another node, that is x2, and this summing point replaced by another node, that is x3. So this takeoff point replaced by another node, that is x4, and this takeoff point and summing point both are present consecutively. Therefore we can replace this by a single node, that is your x5, and it can be replaced by C. It can be replaced by C. So now we can construct the signal flow graph very easily. So here this is x1, this is x2, x3, x4, x5, C. So what is the gain between R and this takeoff point? So gain is 1. Then x1 and x2 gain is also 1. Then x2 and x3 the gain is g1. This is g1, and x3 and x4 the gain is g2. Then x4 and x5 the gain is g3, and this is again gain is 1. So now this is connected to x3 and this is connected to x5. Therefore now we can connect this, x1. So we can connect this to x5. Then the direction is this and positive. Therefore this is g4. And now this is connected to this, that is x5 and x3, x5 and x3, and this is minus h2. Then this is connected to x3 and x2. So first you connect this x4 to x3, x4 to x3, and this is minus h1, and this will be plus h plus 1. This will be also plus h1. So this is connected to x2. Plus h1, x3, and is directly connected to h1. So This is the signal flow graph, and this problem can be solved very easily. So in this way we can convert each and every critical problem uh, by converting to the signal flow graph. Thank you very much for watching this video.